Hey there, it's Miss J. Wanted to go over the series and parallel circuit comparison class assignment that's due Friday the 8th. So in the beginning we have some Tinkercad work. I think you can do those directly from the pictures, being careful that you follow exactly the legs are in the right place, the wires are in the right place, right? So follow the instructions on there. This shows you how to measure resist. You know that the resistor is 330 because you told it that. So you could just type in 330 for this particular answer. Move this over. So I'm going to scroll down to the bottom and do the math with you. Make sure you're adding a screenshot of your working circuit. Let me go over this one real quick. So a circuit schematic. It's going to be the next one. I apologize. This one is a screenshot of your Tinkercad. The circuit schematic is down here. Oh yeah, I've got it here. Make sure your circuit schematic shows just like this, not like an actual battery. You want to show the symbols. Symbol for resistor. Resistor comes first, then the LED. Resistor slows down the current so you don't blow the light bulb. This is what a schematic looks like. You can use a software to use it, but you want to make sure it's a schematic and not an actual battery, not an actual light bulb. And you're good. This one says you need to use Ohm's law to find total current. So it is V equals I times R for Ohm's law. But you want to solve for current. So you're going to move that around, a little tricky, just R to the other side. V divided by R. And then it should be 9 volts divided by 330 ohms. Be careful not to do it upside down. 9 volts divided by 330 ohms. And you can round your answer. Your answer will be in amps, A. Let's put that in there. Okay, when you add your second LED right here, be sure that, and it's really small, so enlarge it on your screen. Be sure that this short negative leg is in the same row as this bent positive leg. And then move your wire from when we first had it set up, move it into this leg out to the rail, the positive rail. So move it right here, just like in the picture. Make sure your resistor stayed at 330 ohms, not kiloohms. Add a screenshot where they're both lit. If you have the multimeter over here, it'll be lit. You'll be good. Okay, this one asks you to move your multimeter onto this one. I had to move my second light bulb in order to connect it so I could see it. Just make sure they're in the same row, and then you're good. Resistance is still 330 ohms. Your volts and your amps will change. Your volts will change considerably because you've got 2 on here. So be careful with that. Play with that. It does turn, when you hit volts, it's going to turn this on. When you hit amps, it's going to turn this one off. And that's because you're interfering with it, and that's okay. To draw a schematic for this one, it's the very same as the first one, but you add another light bulb. So you got 9 volt battery, 330 ohm resistor. You had an LED, but let's add another LED. I guess I could have been neater there. Oh well, it's supposed to be a little circle, right? LED. Messed up. So we add that, throw that in there. Okay, these are the ones I wanted to go over with you right now. So there's 5 of them. I'll try to be quick. We're just looking at resistance here. So it says, number 1, the resistance is equal to 470 ohms. We don't know the current. I is equal to what? What are the amps? And then the voltage is 3.5 volts. So Ohm's law, we know that V is equal to I times R. I want I by itself. So R's got to move over to the other side. So I'm going to say V divided by R equals I. And that is equal to 3.5 volts divided by 470 ohms. My answer, whatever number I get, will be in amps. So in your calculator, 3.5 divided by 470. You don't have to show all that, but do show your formula, which is this one. and your setup. At the very least, this should be on your page. And put in your number, your actual number for your calculator. Remember to pause so you can look at this and then come back. I will do number 2. And I'm just trying to make your video shorter, so pause and look back. All right, number 2, we have a resistor. We don't know what it is. We have current 0.013A. That's I. And then we have voltage. That's the easy one because it's always in V. So we're trying to find resistance. We know Ohm's law. V equals I times R. Get that R isolated by moving the I to the other side of the equal sign. V divided by I equals R. 3.5 volts divided by 0.013A. I write the units here because then I can see my mistakes. If I flip them, by writing the letter, it would raise an alarm and let me know. So in your calculator, 3.5 divided by 0.013, whatever number you get, round it a little bit, and it is in ohms or OHMS. Remember to pause so you can work that out. Number 3 says we have a resistor that is equal to 22 kiloohms. Oops, I messed up my ohms. That's what it is though. And then current is equal to 1.4 milliamps. And then voltage, we don't know. What's the volts? Okay, so background, if you have kiloohms and milliamps, they can work together. You can do any sort of multiplication and division you need to. If you have ohms and amps, they can work together. You can do anything you need to. If they're mixed, kiloohms and amps, you have to fix one of them. If they're mixed milliamps and ohms, you have to fix one of them. I usually try to get back to this one. For this problem, because they're in kiloohms and milliamps, you don't need to do anything. So V is equal to I times R, Ohm's law. V is equal to 1.4 milliamps times 22 kiloohms. Your answer will be 1.4 times 22. Whatever you get, your number will be in volts. Remember to pause so you can work it out. I'll go a little on to the next one so that I don't keep your video too long. All right. So number 4. You have to look at the picture and say, hey, this is completely open going around here. There are no voltage drops going through my circuit, so I am in series. You have to make that designation because they don't always tell you. They'll say, hey, find the total resistance for this circuit. They don't always remember to say, hey, this is a series circuit. So you have to watch that wording on a test, an exam. So first things first, formula. Total resistance in a series circuit is equal to adding all the resistors together. IC3. So there are 3 resistors, R1 plus R2 plus R3. That happens so often people think it's the formula. The formula is actually however many resistors you have. So this could go on 50, 100. You know, Christmas lights, you can have 100 on a string, 200 on a string. That happens. Okay, I also see that I have 820 ohms, and I have 1.2 kiloohms, and I have 150 ohms. If I add it like this, I have a problem. I need to fix kiloohms. So to do that, it's 1.2 times 1,000, or you could just move the decimal 3 places, 1, 2, 3, and you end up with 1,200. So move it in your head, use your calculator, whatever makes you happy. The final numbers to go in your calculator, 820 plus 1,200 plus 150. Very straightforward. Answer is resistance total resistance is equal to this addition in ohms. Always state your answer. Don't just put a number on the end here and call it a day. You need to state your answer. Not to nitpick, but you know, college will weed you through. So you get this wrong, they start picking the people who get it right to go on to the next course. Okay, so straightforward. We love series. Series is easy. It can stay here all day long. Let's look at number 5. So I'm looking at the picture. I can see that this is parallel because I have voltage dropping here. The resistors are breaking in the middle here. It's not open like the last one. So I'm going to use this formula here. But I'm going to change it into this. I don't mean to confuse you by giving you 2. This is how it shows up on a formula sheet. So you have to move it this way. Don't be fancy and use it this way. Go ahead and switch it and use it this way. So I'm going to flip over. Remember that it's also however many resistors you have. This has 3, so it's R1, R2, R3. If it had 20, this goes on underneath the 1 all the way to 20. So be careful with that. So let's do parallel circuit, number 5, total resistance is equal to 1 divided by 1 over the first, the second, the third. So let's put these guys all into the same thing. We have 5.6 kilo ohms for the first one. We have 680 ohms for the second one. That's regular ohms. And then 8.2 kilo ohms for the third. So let's go ahead and change those. We're starting to get familiar. We're multiplying by 1,000. So 5,600 ohms, 8,200 ohms. Most people will mess up right there and then you're stuck. Everything's wrong. So what's that? All ohms, right? Okay, so I'm going to have 1 over 5,600 plus 1 over 680 plus 1 over 8,200. The best thing you can do is put it in your calculator all in one straight shot. We're going to continue this way and then we'll do it in the calculator so we see it. Oh, I'm sorry. Let's do that. All right, calculator, come here, please. So let's take a look at the calculator. If we were to do the bottom row and put them in decimals and add them together, we have to remember to come back and do 1 divided by that answer. So 1 divided by 5,600, that's the first resistor, gives us this 1.787. Common mistake here is that people forget, see this E, -4? Look at the difference on my calculator. I'm on a regular scientific calculator. I say 1 divided by 5,600. And it's a decimal. So the difference is on the calculator here, it says E -4. So it's the settings on your calculator that tell you this. So you have to be able to recognize both. So if it says E -4, I need to take this decimal and move it over 4 times. 1 takes one of them, and then 3 more zeros. So see it here? 3 more zeros. It's the same number. This number and this number are exactly the same number. You want to use the decimal one. So in here, excuse me, I'm going to do 0.000178571. Don't round yet, it's too soon. That's why we use a calculator for the whole thing. All right, the second resistor is pretty straightforward. 1 divided by 680 should give us a nice decimal. And that is 0.001470. I can round here because I hit a 0. I'm good. That means it got really tiny. That was 1 divided by 680. And then the last one is 1 divided by 8,200. Remember, if your calculator gives you an answer with that negative e to the -4, you want to move your decimal. So I got e to the -4, scientific notation. I want to move this 4 places to the left. So I'm going to have 3 zeros there because the 1 takes up a place. 0.00012,195. So I got really big. Add those together, take 1 divided by that, and you get your answer. So I'm going to move this over here. And let's take a look at how to put it in your calculator specifically. So get rid of this, get rid of that. Your answer should be in the 500 range. So to put this in your calculator, the whole thing, right? We'll take this, put it in our calculator. We would say 1 divided by, and then I need to get the whole bottom equation. So I'm going to put parentheses around the whole equation, but then I need parentheses in between each one of these so that the calculator knows to separate between the pluses. So second parentheses, 1 divided by 5,600, close, plus, open. When I say open, I mean parentheses, plus 8200. So I close my parentheses here, but I need to close it for the whole equation. Right? So always have pairs. This is a pair, that's a pair, that's a pair, that's a pair. Always have pairs. This one doesn't need one, although you could put it around the whole thing, but no, not necessary. So to put it in your calculator, I haven't figured it out on my iPhone. I can do it. It doesn't show me the parentheses. So I'm sure it does. I just don't know how to do it. Let me go here. Nope. So I can slide up a little bit. Okay, so you enter in 1 divided by parentheses. Move over a little bit. And you need that second parenthesis there so you can get this fraction. Parentheses. 1 divided by 5,600, close parentheses, plus sign, open parentheses, 1 divided by 680, close parentheses, plus sign, open parentheses, 1 divided by 8,200, close parentheses. But remember how you wrote it here. You don't have to write it, but you want to make sure you don't forget. If you don't close this, you'll get a syntax error. So that's double. And that's so to show this whole thing right here. Hit enter. You should get a nice big 500 number. Thanks for watching. Good luck with this.